Okay, so this first video is going to be 1.0 domain and range, and it should feel like a review. Now, after I go with the title, I jump right into the objectives. So our first objective is to graph single variable inequalities on a number line, and our second objective is to review domain and range of any graphed function. Now, the first one is a review to get us into the second one. Now you'll see I like to put a lot of vocabulary words. So our first one is inequality. And the reason why I do this is we need to have the same math language in order for us to effectively communicate about math, right? If you're saying that thing over there in conversation with me, it's not clear. If you're reading something about math, they're going to use the terminology. So I am going to expect that you guys use this language with me. So we have a word here, inequality, and it is a math sentence that compares expressions. And expressions are, it's really anything. X is an expression. X plus 2 is an expression. 12 by itself is an expression. So when we say we're comparing expression, we're just comparing two of those things, maybe sometimes more. So I can say X is greater than 3. That would be our first symbol, right? And then we can do Z is less than 5. Now, both of these are very similar in the fact that the number you see on the other side cannot be a solution for the variable. So when I plug something in for X, I'm looking for a true statement. So 4 is greater than 3, right? 5 is greater than 1. Those are all true. But if I plug in the number 3 is greater than 3, that's false. Okay, because 3 is not greater than 3. Now, just as a reminder, the big side opens up to the bigger number, and then it points to the smaller number. Okay, so what I just drew there was like the alligator chomping the bigger side. Okay, and a greater than and less than, it's really the same symbol, right? They're just reversed. So I can read this right here. I can say X is greater than 3, or I can say 3 is less than X. Okay. Now, Z is less than 5. I think we're pretty good on that one, right? We're saying all the values that can be plugged into Z is less than 5. And then let's go to Y is greater than or equal to, let's do -2. Very similar, but it could be -2 now as a correct solution. So I could say 5 is greater than or equal to -2. I could say 0 is greater than or equal to -2. I can even say -2 is greater than or equal to -2. It just needs to satisfy the greater than part or the or equal to. And then the same thing here. I can do A is less than or equal to -5. So -10 is less than or equal to -5. That's true. -5 is less than or equal to -5. That's true also. Okay. Yeah. Okay. So if you're seeing this one, it's because you're in honors. We've included some different types of inequalities for you. And I'm gonna hit them as we go. So we have our first one, X is less than 2. It's kind of a standard inequality. We want to graph this on a number line. So that's my eraser. I'm gonna fill in some details with my number line, like so. And then I'm gonna go right into plotting it. Now we want our line to represent all of the things that would be true for X, right? So if I look at X, 0 is less than 2, -10 is less than 2, 2 is not less than 2, that would be false. So I'm going to use an open dot on 2 because 2 cannot be a solution. Let me zoom in a little bit here, just a little bit. And I need to fill into the direction of the solution. So I can see 0 is less than 2, that's good. -1 is less than 2, that's good. 3 is less than 2, that's not good. Right, 4 is less than 2, that's not good. So I'm filling in to the left. Okay, that's all of the numbers that I can plug in for X that would be true. Now these other ones here are called compound inequalities. All right, we have an and compound inequality, and we have an or compound inequality. Okay, and they are both they're very similar but a little bit different. Now you look at this one, it says -1 is less than M. And then it says that is less than 5. We have two conditions now. And the reason why it's an and is because M has to satisfy both of them. And you could really also write this separately. You could say -1 is less than M and M is less than 5. 5. You could do it both ways. But because we see them right together like that, we just mash it into a single line, single statement. All right. And that's actually kind of helpful too, because if I put some numbers, let's move this left. I got 0, -1, -2 here, 1, 2, 3, 4, 5. Let's go 6 a little bit further. I can see that I have a less than here. So I need an open dot on -1. Sorry, I'm putting it above. Let me erase that. Put it right here, open dot. That doesn't look very open. Okay, there we go, open dot. And again, I have a less than at 5, so I'm putting an open dot on 5. And m is going to be all the numbers in between, just like it's in between -1 and 5. Okay. Now, the or, and also, you know, I'm looking at my examples here, and I'm seeing that I'm using a lot of just less thans, right? Or just greater thans. It is okay if I had a compound inequality that was like this. It's okay that there, you know, one isn't or equal to, and I would do an open dot and a closed dot and fill in between. That's totally fine. You can have many combinations, all right? Now, the or is a little bit different, okay? The or, we're saying that there's not actually going to be an overlap. X is less than -2 or X is greater than 3. A number that's true for this first one is not going to be true for the second one. I can prove that. -4 is less than -2, right? But -4 is not greater than 3. That one doesn't work. So they both are very, very separate. So I'm going to graph them like it's two individuals. I got X is less than -2, so I'm going to put some numbers here. Let me zoom in a little bit for you guys. 3, okay. And my first one, X less than -2, I got an open dot on -2, and all my solutions are to the left, because that's what makes it true. And then for X is greater than 3, again, I have an open dot, which also, it just so happens I picked the same ones. You could have a mix in of open and closed dots. It's going to be all the numbers greater than 3, so that is to the right. And so when you look at the differences between these two, you can see the compound inequality, they're kind of facing in between, right? Boom, right in between each other. And then for the or, because they're very different, they're bouncing. One's going to the left, one's going to the right. And you're going to see that a lot, okay? Now, let's give you guys some problems to try. So let's go to the next one. I want you guys to pause and try it. If you're on Edpuzzle, it'll do it for you. And really give these a go, okay? You should know how to do these before we get to class, or be ready to ask questions about them when we get to class. Okay, so for this video, we're halfway through a video. Okay, so we're going to be writing inequalities from a graph. We're going to be focusing on compound inequalities, simply because it's like two regular ones, right? So this first one and the second one, we're going to start off just by identifying are they ands or are they ors. Now we can see this one here is they're facing opposite directions, so we can tell off the bat that's an or. The other one, they're facing together, so we know that's an and. Now when writing these, you just got to extract the information. So I can see this dot is on 3, so I'm going to put a 3. It's an open dot, so I know we don't have any or equal to's. And I just kind of follow its directions. Going to the left, this is all the numbers less than. 2 is less than 3. 1 is less than 3. 0 is less than 3, right? And I could write that. 0 is less than 3. 1 is less than 3. 2 is less than 3. So this must be where my X goes. X is less than 3. And then I'm going to put an or. And then I find I have a 5 here, right? So that's going to be my number. I have an open dot, so no or equal to's. And 6 is greater than 5. 7 is greater than 5. 8 is greater than 5. So I'm going to do an X is greater than 5. And this would be my inequality from a graph, all right? Now, you could have written it the other way. You could have said that 5 is less than X, because that still is also X is greater than 5. But I generally like to keep my X's, my variables on the left, because if you do that, you can see it kind of follow the arrows, okay? That they face the same direction. Now with and, I want you to think of this, you know, we have that compound statement where it's all together, and you can really just see it here, right? I have a 0, I have a 3, I have X in between, right? My left side has a closed dot, so I know I need the or equal to, and X would be greater than 0 here, right? Because 1, 2, So x is less than or equal to, or 0 is less than or equal to x. And on the right, I have the open dot. X is now less than 3. I can fill it in like that. I mean, you can see it lining up so well, okay? And that would be it. Now, if you wanted to, you could separate them like this. If it makes you, if you are more comfortable with that, I am fine with that. But you do need to be able to also read it as a single statement, okay? Now, if you need to keep writing these, pause the video. But I want you to now try 2 of your own and then make sure you're ready to come to class to talk about them. So here we have our third concept, and it's going to be about domain and range and finding it from a graph, okay? Now, all of these are graphed functions, and a function takes a domain as an input and gets a range as an output. So if I had a function, I'm just going to write the word function, but it would be things like f of x equals x or f of x equals x plus 2. The domain goes into it. You do some calculating, and out pops the range. So the domain is also your x values, and your range is your y values. So when I ask what the domain is of a function, I'm only asking you at this point to tell me the story about the x values. And if I look at this first graph here, I know we don't see these arrows, but this is a quadratic function, and it is expanding in both directions. And it's just always getting wider and wider and wider. So when you look at this, it's almost like all of the numbers for x could be an input, right? Because all of these, all these points tells you an x and a y, an input and an output. So everything in the x value is a solution. So I'm going to do a squiggly line through the x so that I know all of them are solutions. And the way we would say that is our domain is all real numbers, because it's got them all except for the irrational numbers, right? Now for the y-axis, we can see that there's a stop, right? I don't see any -10, -5 numbers as outputs. I only am seeing the positive numbers. So I'm going to look at my y-axis. I'm going to put a dot here. And these squiggly lines you don't have to do. I'm doing this so it's easier for you to see what I'm talking about because we're digital. And you can see that it's all of the y values up, okay? And only the y values up. So the way we do that is with an inequality, which is why we reviewed them. We have range is y is greater than or equal to 0. And if you think of those graphs that we were doing, that blue squiggly line I did is kind of the same thing as that single variable being graphed, right? We had a starting point here, it would be 0, and we're going all the way to positive infinity. That's why we got y is greater than or equal to 0, because it's also on 0, okay? So let's look at the next one. And I'll keep that in view. This one's cut off a little bit here, right? When I look at the x, so we're going to look at only domain first. I see I have, I have 0 as a value. I got 1, 2, and so forth, all of those. And this is going on and expanding. And so that's going to go this way, okay? So my domain is no longer all real numbers here. I can see that it's starting at 0, and this would be x. So x is greater than or equal to 0. Now, if it wasn't a solution, like if it was, for an example, where x is greater than 0, you would see an open dot on that area to denote that it's not an or equal to, okay? And then we got to look at the y. Let me get that, okay. So same thing here, went all the way down to 0 for the y, so I'm going to put that and squiggly up. We have all of these values, okay? Now let's look at a point. We have a point here, right? We can see down to the x, we can see over to the y, all right? Those squiggly lines you draw, you should be able to do something like that to make sure they're in the right direction. And then we have our range, we'll do that in blue. And here this is going to be y is greater than or equal to 0, okay? So they're both kind of cut off. This function cannot take a -5 as an input. Can't take a -1, right? It's going to only take 0 and on. And then let's go to this one. Now, this is a linear function. It's going on in both directions. And you start to look at the x-axis. Well, I go to the right, well, I'm getting everything. And go to the left, well, I'm getting everything, right? Because it continues to be on that graph. I look up and down. Hey, wait a minute. I go down, it keeps going. Okay, I go up, it keeps going. So for both of these, for domain and range, I'm just going to put D, it's all real numbers. And you're really going to see that for all of your linear functions, except if there's a constraint put in where it got cut off at a specific point. Okay. So hopefully you can see why we reviewed inequalities. You're going to be using them a lot for domain and range. We are just basically using inequalities to tell the story of what are my domain values and what are my range values. Now, you got 2 to do on your own. These look a little bit different. Don't worry about the way that they look. Focus on what x values are there, what y values are there, right? What domain and what range. Use your inequalities. Use your all real numbers when it's appropriate. Okay, so the last thing I want to ask you guys is to kind of think about this situation, right? Does it really matter which side of the inequality the variable is? So is x greater than 2 the same thing as 2 is less than x? And is x is greater than -2 the same thing as -2 is greater than x? Okay, because this is something I see confuse students a lot. All right, and then finally, okay, come prepared with questions to class. If you were trying the problems and you were really confused, first thing we get to class, that's what I want to talk about, okay? Making these videos has actually been really, really hard. So sometimes I might be forgetting to put something in them. So just be ready to ask questions. If you don't get it at the end of this video, keep trying, and then we'll try and cover whatever we can when we get to class, okay?